Welcome back. In the previous sequence, we have seen that the role of each component of a tuple is determined by its position. But we have also seen that it is easy to use a wrong index. Maybe if we could name each component, it would help us avoid that kind of programming errors. So to define a record type, we use braces and a list of field declaration. So here I define a field named x, whose type is int, and another field y, whose type is int. This type definition is accepted by the compiler. And now if I want to represent the origin, I use braces, and then I have to give the value for each field. Here I say that x is equal to 0 and that y is equal to 0. And OCaml is able to infer that this definition of a record has actually the type point2D. It is easy to define a conversion function from pair to points, but here you can notice that instead of writing that x is equal to x, I can just write x here. By a kind of punning, we can use a shorter definition for fields. So I can define 2 points. And now another record type for a box, which will use my record type definition for point, like that. It's easy to have this accepted by OCaml, and I can define a box in which the left upper corner is equal to my first point, A, and the right lower corner is equal to B. Finally, imagine that you want the minimal abscissa of the 2 points of your box. So you will find it in the left upper corner of your box. So here I write a pattern which will observe the value of this left upper corner, and to observe this value, I use another pattern that will just name the field x, and I just want to return the value of that field here, like that. This definition is accepted by OCaml, and it has type box arrow int. So now that we have seen several examples of record construction and observation, let us review the general rules to use them. The first thing is the fact that in exchange to these extra checks that the compiler is doing, you have to declare record types, whereas you don't have to do so when you are using tuple types. The syntax to declare a record type is the following. You first use the keyword type, then the name of your type identifier, and after that, between 2 braces, you have to enumerate the different name of your fields and the type of these fields. One constraint is the fact that all field names must be distinct. And also, it is better, and we'll come back on that, to use names for fields that are not used in other record types. Now, at the level of expression, you can construct a record, again using braces, but now you will have to define each field using the equal signs. And on the left of this equal sign, you will have the name of the field, and at the right of the equal signs, you will have the definition of this field using some expression. So now, if you want to observe a specific field of a record, you can use a dot notation. So you write the expression that evaluates into a record, dot, and after that, the name of the field you want to observe. If you want to observe several fields of a record, you can use a record patterns. And in this record patterns, you will enumerate all the fields that you want to observe, and for each field, you have to specify right after the equal sign the pattern that is used to observe this particular field. What is nice is the fact that you don't have to enumerate all the fields of the record that you are analyzing. You just have to mention the fields that you want to observe. In the machine, a record is represented by a heap allocated block, exactly like a tuple. Now, what kind of programming error you can do when you are manipulating records? The first one is a typo in the name of the field that you are defining or observing. In that case, the compiler is able to detect that just at compile time. So imagine that you have defined this type for 2D point, and you try to define a point, but this time you made a typo and you change y to z. So it's invalid. And OCaml is able to understand that this record field name is not in any record type, so it will reject this definition. So imagine that you have your definition for 2D point, and you have forgotten to give the value for the y field. This time, OCaml is able to point this problem to you, and by seeing that you have indeed a missing field. Another kind of programming error that is very common is when you assign a definition to a field with an expression that has not the same type as the type that was declared for this field. And again, the compiler is able to detect that kind of error. So imagine that you have defined a record type for a person, in which you have a name of type string and an age of type int. Of course, this definition of the record is wrong, because for the age, you have used a string instead of an int. Again, OCaml is able to detect that during type checking. Finally, let me come back on a remark that I've made about how you can share or not the fields between several record types. In modern version of the OCaml compiler, the compiler does its best to disambiguate the usage of labels. But sometimes you can do a mistake because the ambiguity is not intended. So let us define two record types, A and B, and you can notice that the fields of these two records are disjoint. That makes the inference easy. The fact that you are using X and B with the two type int makes it easy for the type checker to infer that this record has type A. So now imagine that you have type T, whose type is a record type with only one field of type bool. If you say now that you have a record with only one field X of type bool, then OCaml does its best and is able to infer that this record has not type A with a missing field, but type T with the right field. But now, if you defined another type U with type X of type int, and you try to check the same expression, now OCaml will reject your program because you only have one field, and this field has not the right type with respect to the last definition of a record with only one field X. So it's rather complex, and the good advice is simply not to share field names between records.